Hello students, we have seen about the Planck's quantum theory, particle nature. Now let us discuss about photoelectric effect. So generally H. In 1887 he explained about in which electrons were ejected when certain metals are we have taken like potassium, rubidium means the electrons are exposed to the beam of light in a metal, so that one we call it as what? Photoelectric effect. So generally Hertz have discovered this experiment. So what is photoelectric effect? So photoelectric effect is nothing but what here? When light is instant upon metals like potassium and rubidium. When light is instant upon metals like potassium and rubidium, they emit electrons. Is known as what? Is known as photoelectric effect. So what is photoelectric effect? Photoelectric effect is nothing but what here? Photoelectric effect was discovered by H. So whenever the light is instanting upon metals like potassium and rubidium, so it emits what? It emits electrons. That one we call it as photoelectric effect. So here let us take a tube, vacuum chamber. Okay. So whenever you are taking vacuum chamber, so see here clearly. So this is a metal surface. This is electrons. Okay. So this is vacuum chamber. This is a anemometer we are having, ammeter. Battery. And this is a detector. Okay. So here what I have told you, photoelectric effect is nothing but when we are lighting means it is striking. So the light is striking a metallic surface. We have taken vacuum chamber, a clean metal surface inside a vacuum chamber. So here if you have observed, the electrons are ejecting. So means what? It is escaping outside. So means what? From the metal the electrons are coming. So whenever we kept a current here from the battery, whatever electrons is passing here, okay, so these electrons are escaping from the metal surface, and these are counted by a detector, means that measures their kinetic energy. So this is about the photoelectric effect it is going to explain. So what? For any metal surface to emit electrons, so it should have a light of certain minimum frequency is required. If you take any electrons to eject outside, it should have certain frequency. Okay. So here what we have to take generally, so the electrons are ejected from the clean surface when the beam of light surface is striking the light beam and electrons are coming outside from the metals. So whenever the light is coming and touching the metal surface, the electrons are coming outside. So that is our first point. And next one, what happens, for example, for any metals, for any metal surface to emit electrons, light of a certain minimum frequency is required. See here, if you take, means if from the metal surface, if any electrons is electing, so the light should have certain frequency. So at least minimum frequency if it is have, the electrons can remove from the metal surface. So this one we call it as what, means this one we call it as threshold energy. Okay, so here this is nothing but threshold, the minimum energy which is having, that one we call it as threshold energy. So by this we can say the electrons ejecting, electrons is directly proportional to intensity of the brightness of light, we can say. Okay, so whenever the electrons is ejecting, it mainly depends upon the wavelength of the light also, we can say. So here generally we have seen that photoelectric effect is not observed, but at a frequency mu is greater than mu naught, the ejected electrons comes out with certain kinetic energy. So it is having certain kinetic energy. Why it is having kinetic energy, means it increases, means the kinetic energy of these electrons increases. If electrons increases, the intensity of the light also increases. Means what, if suppose when a light of frequency is very less we are having, when a light of frequency less than the threshold frequency, when a light of frequency less than the threshold frequency is used, electrons are not emitted whatever be the intensity of the light. So see here, if suppose the light of a frequency is, what is threshold energy, I have told you minimum frequency is required to emit electron from the metal surface, we call it as threshold energy. So whenever the frequency is less than the threshold energy, then electrons will not emit whatever intensity. If suppose the intensity is high also, it is not going to eliminate electrons, remove electrons. Why? Because it is having very less frequency of light compared to the threshold energy. So then automatically what happens here, the kinetic energy of a emitted electron so the kinetic energy of electron is given as what here, K is nothing but generally as we know half mv square. Okay, so this can be written as half mu minus half mu naught. Why? Because mu is greater than here mu naught frequency. So where mu is frequency of light, here, mu naught is nothing but here threshold frequency. Okay, where h mu is equals to as a work plus kinetic energy. So h mu is equals to h mu naught plus k. Okay, so this is nothing but general equation as we know. So here k is nothing but what here, half mv square. So we can write half mv square here. So to get the h mu, we are writing here h mu naught plus k. So here on the basis of photoelectric effect, Einstein suggested that light consists of particle called photons. Each photon is a quantum of light. So according to Einstein, light is not only emitted or absorbed but also propagated in the form of photons. So what here, on the basis of photoelectric effect, Einstein, what he had suggested? Einstein suggested that light consists of particles called photons. So means what here? Each photon is a quantum of light. Okay, so means what here, basing upon the photoelectric effect, Einstein what he has said, every particle of light we are having photons. Photon is not here quantum of light. So according to Einstein, what, according to Einstein we can say light is not only emitted or observed but also propagated in the form of photons, we can say. Propagated in the form of photons. So this is nothing but photoelectric effect. Okay, so what is photoelectric effect? We can say photoelectric effect was discovered by H. Hertz in 1887. So when it is instant upon metals like potassium, rubidium, they emit electrons, is known as photoelectric effect. Okay, so we are having threshold energy and also normal frequency. When threshold energy is less than frequency is less than threshold energy, we can't say emit electrons. Why? Because whatever the intensity is more, also the electrons is not used. So okay, this is about particle nature and wave nature. So now let us discuss about dual behavior. So what is dual behavior? Both particle nature, dual behavior of electromagnetic radiation. So generally particle of light, on the one hand it could explain black body radiation and photoelectric effect, but on the other hand it was not consistent with the wave behavior light. Why? Because it is having interference and diffraction. The only we are in dilemma of that, whether it is a, if you have observed wave nature. Coming to wave nature, what I have explained you, dual character of electromagnetic radiation, it will explains about both particle and wave nature, yes or no? So but coming to wave nature, we are having black body radiation, which he could explain about. Means it is not consistent with the wave behavior of light. Why? Because it is having both interference and diffraction. So the only way to resolve, means we are in dilemma whether it is having both particular wave nature, means light is having, we can say light is having dual behavior, means what, it can exhibit both wave nature and also particle nature, as we have seen, depending upon the experiment what we have find that. So depending upon the experiment we find out that light behaves either as a wave or as a stream of particles. So when interaction, radiation is interacting with the matter, so automatically what happening here, it displays particle like properties and also wave like properties, both interference and diffraction, so which it exhibits or it propagates. The concept was totally wave what he had told, that matter and radiation long time to become convenience. So it is exhibiting both. Under the microscopic particles like electrons, it will exhibit wave and particle nature. So this is about dual behavior of electromagnetic radiation. So tomorrow let us discuss about the next topic. Thank you.